welcome to the atomic multiverse. Looking at all these things, which may or may not be related, they may be disparate or they may be connected. It's yet to be determined. All these things on the board here, take them all in right now because they're going to disappear again in a minute. That being one of the features of the multiverse, you know. You never know quite where anything is. These are the brains of the multiverse, also known as the bulk in cosmological terms. These are the positions that we might occupy within that bulk framework. We'll talk about the slices of toast element a little later on. This is the atom, hence atomic, and that's the nucleus with the proton and the neutron there in the middle, made of quarks, remember, and gluons. Don't forget the gluons. And these are the electrons, or the electron, depending on which way you look at it, really. It could be many electrons or it could be one electron. We'll see later. And here is the ubiquitous photon coming in, doing its stuff, zipping out again, however that actually happens. And these are the various frequencies of the electron in its oscillation process. So that in a nutshell is what I'm going to talk about today. Hope you thoroughly enjoy it, and I'll see you in another dimension to have a look at a couple of concepts that affect the way we live and what we do. Hopefully today I can invite you to go into some deep thinking in terms of our own existence and the existence of everything else that's around us. The relationship between the electron and the photon runs deep. It really does. There seems to be a kind of a cross-reference, a cross-pollination, if you like, between the two. Not only do we have this entangled relationship between the electron and the photon happening on a permanent basis, but we also have a kind of a cross-reference of reference. We refer to the electromagnetic spectrum, and the electromagnetic spectrum refers to a spectrum occupied by photons. Electricity, the electronics. This relates to the electron and the electron's mode of behaviour, creating what we know to be electricity, for example. What part the photon plays in this? Well, we can hazard some guesses and the maths can come up with some neat answers, but at the end of the day, this relationship between the electron and the photon seems to be so closely entwined that it's kind of almost difficult to separate. Because as we move beyond the parameters of old physics and into new physics, and the ways of thinking that are going to permeate through these questions and these mysteries and get beyond them, it's going to require a completely different viewpoint on how these particles interact, how they relate, how they behave. And perhaps the multiverse will hold some clues as to those behaviours, their strangeness, their incomprehensibility. This relates directly to us, and there is no escaping that, which is why there is no escaping the interest in quantum mechanics and the whole bedrock of investigation that is very likely to arise from that. Although I didn't want to go into too much detail about even the conversation that brought me here again, I did think it was worth reminding ourselves of what Nikola Tesla was doing, because Nikola Tesla died before he could complete a very important project which would have essentially have ensured energy provision from the zero-point field on an indefinite basis. How many versions of Wordly are there across the multiverse? Well, we don't know the answer to that. One thing we do know is that the multiverse probably exists. in some form or another. And the slices of toast that typify the way it's portrayed in physics are a little bit too neat for comfort, given that nature doesn't particularly like straight lines. The electrons and the electron shells, are they interchangeable from one dimension to another? Where does the photon go? I have heard that the photon incoming doesn't exist once the electron has it. It's not absorbed, it just gives up its energy and disappears. My question back was, well, what about the photon that's emitted then? Where does that come from? Where does it come from? Where does it go? Given that the oscillation speed is faster the further away from the nucleus the electron is residing, within the shell valence, whatever that may look like, it would appear that the energy of the electron and the energy quotient of the photon are somehow linked. But as with many other quandaries really in quantum mechanics, we've got to ask ourselves where these energies originate. Just while we're at it, talking about the photon coming in and being absorbed by the electron and then subsequently emitted by the electron again, as far as our language can define it, I want to ask a question here, because if the photon as an elementary particle is absorbed or taken in some way by the electron and is said, for argument's sake, to disappear because it's just giving up its energy to the electron, which then absorbs it, jumps up a level, the electron then emits a photon when it jumps down a level. So should we not be asking ourselves, well, where does that photon appear from? Now you could argue that the electron is just emitting a little packet of energy and that becomes a photon. If a photon can so magically appear, disappear, be absorbed, be omitted, emitted, how many versions of that are there? Then if this can so readily happen in our everyday surroundings, then what can be said of the speed of light? The speed of a particle that essentially isn't really a particle at all. Most of the time it's just an energy probability, a quotient package that's waiting to materialize in some material way. The speed of energy? Come on. Let's take this. Nucleus. Constantly fluxing, constantly in flow in the quark-gluon mix. Flavour mixing, colour mixing. All happening all once, all at the same time, continually. This whirl that creates the gluon quark plasma, it's the material that forms the proton and the neutron. And there is some disparity because the actual mass, energy, weight of the proton and the neutron doesn't seem to marry up with the quark matter that it consists of. Why? Where does it come from? Where does it go? This morning I woke up and checked my phone, as most people probably do these days in this peculiar world we live in, to find an essay, quite a short essay, by Sir Roger Penrose on Erwin Schrödinger. And I'd like to read some of this to you now, because I think it's relevant. I always found his writing to be compelling, and there was an excitement of discovery with the prospect of gaining some genuinely new understanding about this mysterious world in which we live. None of his writings possess more of this quality than his short classic, What is Life?, which, as I now realise, must surely rank among the most influential of science writings this century. It represents a powerful attempt to comprehend some of the genuine mysteries of life, made by a physicist whose own deep insights have done so much to change the way in which we understand what the world is made of. The book's cross-disciplinary sweep was unusual for its time, yet it is written with an endearing, if perhaps disarming, modesty at a level that makes it accessible to non-specialists and to the young who might aspire to be scientists. Indeed, many scientists who have made such fundamental contributions in biology, such as J.B.S. Haldane and Francis Crick, have admitted to being strongly influenced by, although not always in complete agreement with, the broad-ranging ideas put forward by this highly original and profoundly thoughtful physicist. It makes points that, once they are grasped, have a ring of almost self-evident truth. Yet they are still blindly ignored by a disconcertingly large proportion of people who should know better. How often do we still hear that quantum effects can have little relevance? This serves to emphasize the continuing relevance that Schrödinger's "What is life?" has for us today. It is amply worth reading. So that's from Roger Penrose, who earned himself a Nobel Prize in Physics, quite rightly so. He is one of the forerunners, really, of what you might term non-classical thinking. In this episode here, I'm looking at concepts that, for many among the initiated, do not have any correlation whatsoever. There is no correspondence between them, because it has been a feature, as far as I can understand, of quantum mechanical investigation to assume that the quantum mechanics is out there and we are observing it. Dark matter is out there. We're detecting it. There's a separation between our units, our physical, psychological units as human beings, and what is happening out there in the universe that we observe. I feel that's a very hefty mistake, and I think a lot of physicists feel the same way. Here we have an unfathomable, potentially infinite array of macro universes. And here we have the atom, the humble construct of what we are, at work in our physical makeup and the physical makeup of everything that's around us. But this humble atom is doing some quite remarkable things, and those remarkable things cannot readily be explained by the principles of classical physics. Where is the bridge? Are we standing on it? Are we crossing it? What are we doing? Where do we sit? What is our position across the multiverse right now? Bringing things together in a format that makes sense is partly the job of experts, physicists, scientists, mathematicians, and partly the job of those who are simply interested in the matter at hand and want to explore it further. I'd like to introduce a meme of a quote from Albert Einstein. So that's it, folks. I'm going to wrap up this little documentary with you here today. Just give you a reminder of what was originally on the board before it all disappeared into another dimension and another version of itself. I hope you've enjoyed yourselves, and that we see each other very soon. You know where to find me. Lots of love. See you later. Bye.